of literal equations back when we were solving equations. Do we remember how to solve equations for specific variables? So, Hayden, if I wanted to solve number 1 up there for y, what would I have to do? Can you say it out loud? What would you do to get y by itself?
Minus 2x from both sides.
Yep, subtract 2x from both sides. So if I subtract 2x from both sides, then we get y is equal to 3 minus 2x. Why can I not combine the 3 and the negative 2x together? It doesn't have an x. Perfect. They're not like terms. So remember when we did literal equations way back when? Number 2, if I needed to get the x or the y by itself, we could add the x over. So then we get 3y is equal to negative 6 plus x. And then what's the last thing we have to do to get the y by itself? Now when I divide by 3, I need to make sure I divide every single thing by 3, which means the y would just become y. Negative 6 divided by 3 is negative 2. And what would be 1x divided by 3? 1/3 x. Good. 1/3
I have to
x.
do all that, or can I find y equals negative 6 plus x all over 3?
Nope. Do all that. Simplify it out.
Wait, I gotta take a second.
Because remember, I forget when it was, we had something like x over 5, and we said that's the same as 1/5 x, right? So x over 4 would be the same as 1/4 x. What would be 2x over 3 be the same as? 2/3 x. Does everybody see that? What would be 7 over 8? Or 7x over 8, it would be 7/8 x. Okay, so simplify, 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 simplify. All right, number 3, we're going to move the 4x over by subtracting 4x. And then I would have just a negative 2y, don't lose that negative in front of the 2, equals 8 minus 4x. Then what are we going to do?
Plus 2y.
Not plus. What's the operation between the y? Divide. We want it because it's multiplying. So we want to divide. Divide everything by negative 2. So then we get y is equal to 8 divided by negative 2 is negative 4. What's negative 4 divided by negative 2 right here? Positive 2x. Perfect. All right. So that was way back when we did Chapter 2 content. Now let's make sure we're good to go with our beginning of Unit 4 stuff. So can we generate ordered pairs? So when I plug in, let's just make a table. Why not? If I plug in negative 4, what's my output? What's half of negative 4?
Negative 3, or 3 and 2.
Well, half of negative 4 is negative 2. Negative 2 plus 1 is negative 1. When you input negative 2, what do we get? Half of negative 2 is negative 1. Negative 1 plus 1 is 0. Plugging in 0. Half of 0 is 0. 0 plus 1 is 1. Plugging in 2. Half of 2 is 1. 1 plus 1 is 2. Half of 4 is 2. 2 plus 1 is 3. So what would be my ordered pairs? Negative 4, negative 1. Negative 2, 0. 0, 1. 2, 2. 4, 3. All right, we got all of our input outputs, and then we generated ordered pairs from those input outputs.
Okay.
You guys did that back in 4-2.
6. No raging over there.
Is everybody okay with those 4 problems?
Hold on. No.
Okay, so now we're going to throw a word problem at us.
Yeah, I know that.
Are you ready?
Suck 'em.
Okay, so it says scientists can use function notation to make conclusions about rising sea level. Scientists can use a function to make conclusions about the rising sea level. Sea level is rising at an approximate rate of 2.5 millimeters per year. If this rate continues, the function y equals 2.5x can describe how many millimeters y sea level will rise in the next x years. So, y, is that your input or your output? That's your output, right? And we know that output is the same as the dependent variable. I know x will be my input, which is the same as your independent variable. And they gave us a function already of y equals 2.5x. It's not in function notation. That's okay. So now, let's pick some values to do for some inputs. What would be a reasonable domain if my x is representing years?
1, 2, 3, 4, 5.
Yeah, we could. I guess we could technically start at 0 because it would be at 0, right? So if we go 0, 1, 2, 3, 4, why would I not want to do a negative x?
Because you can't have negative years.
Can't have negative years. Perfect. So when we plug in 0 into this rule, my output's going to be 0. When I plug in 1, we get 2.5. What's 2.5 doubled? 5. Add another 2.5, we're at 7.5. Add another 2.5, we're at 9. So now when we go graph it, plot those ordered pairs. So 0, 0.
Miss Crowley, maybe 10.
Oh, is it 10?
Yeah.
Thanks.
Oh, Olivia?
So sorry. So sorry.
Sorry, I was going with it. 0, 0, plot it.
Squish chapstick.
Really? That's what needs to happen right now?
Sorry, I just had to.
1, 2.5. So go to the right, and then up 2.5, put a dot. 2 is at 5, so go to the right, 2 up, 1, 2, 3, 4, 5. 3, 7.5, so right, 3 up, 1, 2, 3, 4, 5, 6, 7.5. And then 4, 10 would put me at, oh my gosh, where's the very top? Is that where it is? Okay, so if this rate continues, that would be our functions. Now let's think about this. Should this be a discrete graph or should it be a continuous graph?
Discrete.
Why could it be continuous?
Oh, it could be continuous because water.
Because it's water. Like it doesn't just all of a sudden go here and then jump,
Good. Never know.
right? Have you seen the ocean do that?
They're like waves. What about waves?
All of a sudden it just like jumps up 2.5? No, it continuously is rising. So I'm going to connect these points and turn it into a continuous graph. Will it stop at 4?
No.
No, it's going to keep
Is it
going.
worse for the ocean to go up more or down more?
Well, your sea level keeps rising. We keep losing land, right?
And so, well, what if it keeps going down?
Well, it's not because our polar ice caps are melting and making more water.
It's just more land.
Well, I don't know. Then things are freezing, right?
Oh, then we can see Atlantic.
So notice what I did here, guys. I put a little arrow up here. And that little arrow means that it's going to go on and on and on and on in that direction. Why would I not put an arrow down here? Because we can't go to the negatives, right? All right. So we follow that. Not that it asked for it, but what would be your domain? Let's do a quick review. It didn't ask for it, but I want you to do it. What would be the domain of that function?
Domain?
0 all the way to what?
4.
Well, infinity, because we put the arrow, right? What would be my range? So what's the lowest y? 0, and it goes all the way up to infinity also. Perfect. How do I know that this is a function?
Because they never it never.
Passes the vertical line test. Perfect.
That's what I meant to say.
Good job. All right, next page.
Wait, what time is class at?
30. Okay, example 1's all done for us. So we're asked to graph the function for the given domain. So here we have a function that doesn't have y solved for, and I'm given a specific domain. So they solved it for y, turned it into y equals something. Once I have it into y equals something, I can use that to come up with my table of values. Here's the input. Input it in, get your output, get your ordered pairs, and then plot it. Okay, so let's try to do the same thing ourselves. Oh, here, it's already solved for us. That's wonderful. So we have the function f of x is equal to x squared minus 3. Here's our domains already there. So let's go ahead and do our inputs. So function f evaluated at -2 is equal to -2 squared minus 3. What is -2 squared? 4 minus 3 is 1. So my ordered pair is -2, 1. Just evaluating the function for the given domain. So now, function evaluated at -1. It's going to be -1 squared, which is +1, minus 3 is -2. So -1 comma -2. F of 0 is equal to 0 squared minus 3. So 0 squared is 0, minus 3 would be -3, so 0, -3. Yeah, that's it. Now we're just going to throw them onto a graph. F of 1, 1 squared minus 3. So 1 minus 3 is -2. So 1 comma -2.
Uh-oh, this is bad.
F of 2, 2 squared minus 3 is 4 minus 3, so 1. So 2 1s. Now can we plot those?
Yeah.
So -2, 1. Left 2, up 1. -1, -2. Left 1, down 2. 0, -3 just goes down 3 from the origin. 1, 2, right 2, down 2. And my last ordered pair, which is 2, 1, would be right 2, up 1.
Are we doing the domain range? Do you want us to do that?
Well, here my domain would be what? They gave it to us. So -2, -1, 0, 1, 2 would be my domain, and my range would be 1, -2, -3, -2, 1, right? All right, questions with that one? Does everybody have it? Did I get rid of it? We're okay? All right, see if you can do this one on your own.
Okay.
Get the y by itself. Oh, they already did it for you. That was nice of them. In the table. You see how they already solved it for you guys? That was nice of them. Huh?
You don't make me.
All right, did you get something similar to that?
Yeah.
Yeah, 411 ends up there in space, but it's okay. 411.
That's how tall.
I'm 6'5".
All right, questions with this example? Okay, so now let's talk about graphing functions using a domain of all real numbers. So if the domain of a function is all real numbers, any number can be used as an input value. This process will produce an infinite number of ordered pairs that satisfy the function. Therefore, arrowheads are drawn at both ends of a smooth line or curve to represent the infinite number of ordered pairs. If a domain is not given to you, you must assume, I would underline that, highlight that, whatever. So if a domain is not given, assume the domain is all real numbers. So how do we do it? Well, we use the function to generate some ordered pairs, just like we did, plot the points, and then connect the points with the line. So example 1's done for us. So here's our function. f of x is equal to negative 1/2 x plus 4. They plotted some values, put them on here, and graphed it. Guys, quiet please.
Sorry.
You think I'm joking. I will hold you here for as long as I think I need to hold you here into lunch. So here's the line of this graph. So can we use this to find our function of f of x? And remember, what does f of x really represent? Y. Remember, f of x is the same as the y. So can you find your y when x is equal to negative 4? Well, where is my x negative 4? Here. Shoot up till we get to the line. At what y value are we at? 6. So f of negative 4 would equal to 6. All right, so let's do another one together. So here is the line 1/3 x plus 2. I want to figure out what f of 3 would equal. So on your x-axis, go to 3. When we go up, where is my y value at that ordered pair?
3.
Well, it's over at 3. So f of 3 would equal to 3. Okay? Not that it's asking for it, but what would be f of 6? F of 6 would equal what number?
4.
Oh, yeah.
No.
Oh, hold on. F of 6 is not on there, is it? Yeah, it is. 4. 4. Perfect. What would be f of 0? 2. Perfect. Does everybody see that?
Yes.
Okay.
I do.
All right. And then on the bottom, it says, recall that real-world situations, you may have to limit the domain to make answers reasonable. For example, quantities such as time, distance, and number of people can be represented using only non-negative values. When both the domain and the range are limited, the function is graphed only in quadrant 1. So here we have a mouse can run 3.5 meters per second. The function is y equals 3.5x. Describe the distance in the meters that the mouse can run, and then graph it. So, could a mouse do 0 seconds? I guess technically we could start at 0. So when we plug in 0, we're doing 3.5 times 0, which is 0. So I get the ordered pair 0, 0. After 1 second, the distance is 3.5. So then I get 1 comma 3.5. After 2 seconds, we are at 7.
Yep.
So 2, 7. After 3 seconds, we are at 10.5. Perfect. Okay, so now if I plot those points, 0, 0, 1, 3.5, just here, 2, 7, oh, running out of space already. Now, because it's continuous, I'm going to connect them. Oops, my 2, 7's not right. And make an arrow going this way. Again, why won't my arrow go this way in the other direction? Because I don't have negative time, right? So on the bottom it says, so to answer the question, a mouse can run about how many meters in 2.5 seconds? If I had to estimate it. 2.5, we're about, 10 point, no, it has to be somewhere between 7 and 10.5. 8.75? So about 8.75 meters. Okay, so for your homework, let's do this. I want you
You want us to finish this?
just do the guided practices for homework.
Okay.
Oh, shit.
Lunch starts at 12:30. You have 5 minutes of pass